Welcome to this tutorial on initializing and deploying source code projects to Kubernetes using the gopaddle's command line utility gpctl. In this session, we will cover the process of installing the command line utility, preparing the gopaddle account, and initializing a GitHub project. Let us start with installing the utility. Under the gopaddle help documents, look for installing and configuring gopaddle command line utility. You can find the steps to install the utility here. gpctl utility can be installed either on a host machine or on a VM or inside a Docker container. Across all these installation scenarios, we must install Docker service on the host machine or on the VM and ensure the Docker service is running. Docker group must exist and the current user must be added to the Docker group. In case of a Docker environment, we must mount the Docker socket and the Docker binary inside the container. Once the Docker service is accessible, we need to validate if the Docker commands work seamlessly within the environment. To validate this setup, we can list the Docker images within the environment without a sudo access. When it comes to user mode, the installation and initialization steps can be executed as a non-root user within a host machine or within a VM. But in case of a Docker environment, the command line utility version 4.2 supports only the root user mode. You can refer to the setup matrix for the steps required for each type of installation environment. Let us now install the dependencies and then download the utility. In this tutorial, we are performing the initialization inside a Docker environment. So let us follow the installation steps under the Docker environment section. Once the dependencies are installed, create a new folder under which we can download the gpctl utility. Download the utility. Perform a checksum to make sure the right binary is downloaded. Set execute permission for the utility. We must set the path variable so that the utility can be discovered. We can use the check dependency flag in the utility to check if all the required dependencies are installed. A succeeded status indicates that all the dependencies are available and the installation process is complete. Let us move on to the next step of preparing the gopaddle account for the initialization process. Under gopaddle help documents, look for initializing a microservice from the scratch section. You can find the support matrix here. Gopaddle version 4.2 supports only long-running processes. Any binary or short-lived application or a library or a terminal-based application cannot be initialized through the gopaddle utility. Only a Java and a Node.js application from a GitHub repository can be onboarded using the utility. As a prerequisite, the initialization process requires a cluster and a Docker registry in the gopaddle account. If we plan to use a managed cluster from AWS, Google or Azure, or use a managed Docker registry from one of these clouds, then we need to register the cloud account first. We need an allocation policy that is optimal to build and run the application. We need the GitHub account to be registered with gopaddle, from where the project can be initialized. In this tutorial, we will be using the gopaddle demo account in the GitHub repository. You can find more information on registering these accounts and registries from the tutorials section in the gopaddle UI. Initialization process follows a discovery, a build and a deploy phase. During the discovery phase, gopaddle detects the environment and the project attributes from the local environment. During the build phase, gopaddle makes use of the user-provided build script and a base image to build the project. The base image acts as a build environment within a Kubernetes cluster. Allocation policy is used to set the size of the build environment. During the build process, gopaddle brings up a Docker container using this base image inside a Kubernetes cluster, clones the project, executes the build script, and prepares the artifacts. Once the build completes, gopaddle prepares a runtime image using the base image and the generated artifact. This runtime image is then pushed to a Docker registry. During the deployment process, the runtime image is deployed in a Kubernetes cluster. Thus, as a prerequisite to the initialization process, we need a cluster, a Docker registry, and a registered source control repository. Once the prerequisites are set up, we can install the Git utility and clone the project in the local environment. Log into the gopaddle account using the email ID and the password. By default, the endpoint will be set to gopaddle portal. But you can override this setup to point to your enterprise or community edition of gopaddle using the endpoint argument. Let us clone the project. Here are a few notes on cloning the project. Currently, gpctl supports only GitHub-based projects. The utility supports both HTTPS and SSH-based cloning. If you have a Docker ignore file in your project, make sure you do not ignore the build output directory. By default, the project root folder is assumed to be the build output directory. The output directory can be overridden using the build output dir argument. In this sample application, the project is preset with the scripts to build, run, validate and stop the project. Based on the nature of the project, you can create these scripts in the project root folder. Build script builds the application, start script starts the application, health check script checks whether the application is running, and the stop script stops the running application. The build script is run during the build phase, the health check and the start scripts are run during the deploy phase. In addition, all these scripts including the stop script are used by gopaddle during the discovery phase. We must pay close attention to the environment variables exposed or utilized within these scripts and within the application. Since gopaddle runs these scripts in isolated environments, an environment variable exposed in one script may not be available in another. Similarly, we must ensure that these scripts are self-sufficient. All the libraries and utilities required for a script must be installed as a part of the script. For instance, if npm command is required by the build script, we must either add a step to install npm command within the build script or choose a base image with npm. In our case, we will be choosing a base image with npm. So we can install npm locally for the time being. Next, let us make sure we are running the utility from the project root folder. Check if a .git folder is present in the current folder. Before we validate the scripts, we must set execute permission for all user scripts. The utility assumes a default timeout of 180 seconds for the build, health check and stop scripts. You can increase this timeout using the timeout argument. Similarly, if the start script takes longer to start the application, using the start await argument, we can increase the duration. By default, the start await is set to 20 seconds. Last but not the least, the start script must bring the application on the intended port. For instance, if a Node.js application is expected to bind on port 3000, but if the port is not available in the local environment, Node.js may automatically pick the next available port. This may break the discovery process. To overcome this scenario, assign a static port to the application while starting the application. Once the scripts are ready, we can validate these scripts locally. Since the start script brings up a long running process, we can validate the health check and stop scripts from a different terminal session. The health check script must exit with status 0. A stop script must terminate the process successfully. Now that we have validated the scripts locally, we need to ensure that the environment is clean and the application is terminated properly. Execute the netstat command and filter the output based on the application name. Since we don't find any node application running, we are ready to initialize the project. From the project root folder, run the gpctl init command with the build, start, stop, and health check scripts as arguments. As soon as you start the command, gopaddle analyzes the project and recognizes it as a JavaScript project. Based on the environment and the nature of the project, gopaddle recommends a few base images to use. This image will be used as the build environment for building the container and for generating the final Docker image for the project. As it analyzes the project, gopaddle identifies any conflicts between the project and the base image. For instance, in this case, gopaddle has identified a conflicting path variable. Let us choose the second option, the default values set inside the base image. Once the base image and the configurations are confirmed, we need to choose the cluster to build and deploy the application. Let us select a cluster. We need to select the Docker registry to push the Docker image and select the size of the build environment. We are all set to build the container. gopaddle creates a container profile based on the discovery and starts building the container. Let us check the gopaddle portal. We can see the build in progress. The build is now complete and gopaddle has started creating the deployment template in the application. It has recognized an application port, which can be exposed externally. For all the external ports, gopaddle automatically assigns an alternate port on the Kubernetes node. Once the application is launched, gopaddle displays an access URL, which can be used to access the application in the browser. In the gopaddle UI, we can see the MERN social application that we initialized. To clean up the deployment and the related resources, we can use the gpctl purge option. This terminates the application and all the related gopaddle resources created during the initialization process. gpctl takes the 4 user scripts as mandatory arguments. It has additional output types like Helm and template to auto-generate and download a Helm chart or create or update a deployment template in gopaddle. Using the config map attribute, you can onboard a subfolder in the project as a Kubernetes config map. You can find a complete list of the supported arguments in the help document. As demonstrated, you can see how quickly we can onboard an application on Kubernetes cluster without having to write Docker or Kubernetes artifacts. gopaddle also adds the DevOps capabilities like continuous monitoring, alerting, notifications, rolling updates and audit controls. This brings us to the end of this tutorial on initializing a project using gopaddle.